Hello, this is Akshay with another video here, and once again this video is going to focus on the combination of resistances attributed to series combination. And the main thing about this very video is that we are gonna discuss the main features involved in this very combination so that we can have a clear-cut idea about this very combination. So let us start here. Firstly, the definition of series combination. Two or more resistors are said to combine in series when they are combined end to end, one after another. Here it is one resistor R1, here it is resistor R2, and here it is resistor R3. Let us combine them end to end in a sequential way. End to end. Here it is one end of this very resistor R1, and it's one end. It's one end. R2. It's one end. Both the ends are connected over here. The another end of R2 resistor over here, and it is connected to the one end of R3 resistor. So both are connected over here. So this very end to end, end to end. This kind of a combination is known as combination in series. So that's it here. That is the definition. Now the secondly, we are gonna just join, or you can say that is we are gonna give the voltage to this very combination, just to take take the main things into account, like current, voltage, resistance in this very series combination. So let us connect this very combination to the two terminals of the battery. Here it is. It is the total voltage. This is the total current flowing through the circuit I. So the firstly we are going to discuss about current, thereafter we are going to come across the voltage, and finally we are going to take on the resultant resistance present in this very combination. So firstly, current. Total current flows through each and every resistor in series combination remains the same. It remains the same. Same means that whatever the current is coming out from the main supply line, it will travel through R1, R2, R3, and if there is any other resistor, the same current will flow through these resistors one after another, because of the reason that current has got only one pathway to flow through. It has got only one pathway to flow through, and that's why the same current I will flow through R1, same current I will flow through R2, and the same current I will flow through R3, and that is the another point to keep in mind. The total current flows through each and every resistor in series combination. Now come to the voltage or the potential difference. What is going to happen to the voltage across each and every resistor present in the combination? Remember, voltage, the job of the voltage or potential difference is to bring one unit charge from one end of the you can say conductor to the another end of the conductor. So here are too many conductors are present. So this very voltage will be used to bring one unit charge from one end to this end. The part of this very voltage will be used to bring one unit charge from this end of the R2 resistor to this end. And similarly, a part of this very voltage will be used to bring one unit charge from this end of R3 resistor to this end. What does it mean? It means that the total voltage is going to distribute amongst the number of resistors present in the series combination. Since there are three resistors, it means a part of the voltage will be used to across R1, another part of voltage will be used across R2, and the remaining part of the voltage will be used across R3, depending upon the factor, that is what is the amount of each and every resistance. So here it is, let the voltage acting across R1, it is V1. Let the voltage acting across R2, it is V2. Here it is. And then let the voltage acting across R3, it is V3. So it is clear that the total voltage is going to be distributed, and it would be distributed among the number of resistors present in the combination. So here, that is the point we have discussed here, that is the potential difference got distributed among the number of resistors present in the series combination. So total voltage is equal to the sum of the potential difference acting across the individual resistance. Here it is, that total voltage V, it is equal to the sum of potential difference, that is, it is V1, here it is V1 acting across R1 plus V2 acting across R2, and it is V3 acting across R3. Since the main voltage V coming from the main supply line has got distributed across the number of resistors present in this very combination, so mathematically speaking, the sum of these parts is always going to be equal to the total voltage of the main supply line, and hence here it is, that is V is equal to V1 plus V2 plus V3. So that is the voltage. So now the final point, that is the fourth one, resultant resistance, means the total resistance of this very combination, and we can have the, and you can say total resistance in this very form, because we are gonna use this three resistors in unison to get one resistor here. Here it is, this is the voltage, and this here it is I. Let the total voltage is so total resistance is RS. RS means the total resistance in series combination. So let us have a view about RS here. So here is the resultant resistance, as we have understood here, that is in series combination the voltage got distributed across the number of resistors. There you are, V is equal to V1 plus V2 plus V3. Now we are gonna use Ohm's law, and but we are gonna get, this is the, you can say, a triangular technique we have learnt. It is V, it is I, and it is R. Since you can see here it is voltage, voltage, voltage. So V is equal to IR. Here it is V, it is the total voltage, is equal to the product of total current and the total resistance. Total current is I, but the total resistance we have taken as RS. So there you are, it is IRS. Here it is total current I, and RS is the total resistance or resultant resistance, and it is V1, it is V1 IR1. Here it is V1 current flowing through R1, it is I, here it is I, and the resistance is R1. Ohm's law, by applying Ohm's law, V1 is equal to IR1 plus V2, V product of current and the resistance, V2 current, same current flowing through the each and every resistor, and the resistance is R2 plus V3. Here it is V3, the same total current flows through each and every resistor. It means the current flowing through R3 is I, here it is I, and the resistance is R3. There you are. So, or IRS, I is common, R1 plus R2 plus R3, and this I goes out here, and therefore resultant resistance in series combination RS is the sum of individual resistances R1 plus R2 plus R3. And with that we come to the main definition of the resultant resistance in the series combination, and that says here quite clearly, you can put it in English language, that resultant resistance in the series combination is always equal, yes, is always equal to the arithmetic sum of individual resistances present in that very combination. So that's the resultant resistance R1 plus R2 plus R3. And finally, let me tell you here that the resultant resistance in the series combination is always greater than any other resistance present in that very combination. It is always greater than. Let me take you a very simple example here. It is 2 ohm and it is also 2 ohm, and it is connected across the voltage V here. Here it is, and the current I is flowing. If we want to find out the total resistance of this very combination, we are going to use this very formula by identifying what kind of combination it is. It is series combination, and the in series combination, the resultant resistance is the sum of the individual resistances. That is, Rs is equal to 2 ohm plus 2 ohm. And what does it comes out to be? 2 plus 2, it is equal to 4 ohm. This is the resultant resistance. So what I am telling you here, that is resultant resistance is always greater than the individual resistance present in the combination. That whatever the total resistance in the series combination, it would always be greater than the individual resistance present in that very combination. Means we got the total resistance 4 ohm. It means 4 ohm is greater than 2 ohm. 4 ohm is also greater than 2 ohm. So mathematically speaking, in series combination, the overall or the total resistance of that very combination is always greater, or you can say it is always heavier. So these are the main bullet point about the combination in series, and that's it here.